Hey, good afternoon, everyone. So today in class, we went very quickly through 2-7. So I thought it would be a good idea to give you an example of what's going on there. So here we go. If we're given 1 minus root 6 and negative 3 halves as roots, we want to write a cubic equation with integral coefficients. Integral coefficients, that sounds like a big word, but it just means that the number that you're going to multiply times your A term will be an integer, or times your B term will be an integer. So, not a big deal. So we're given the roots 1 minus the square root of 6 and negative 3 halves. Now this is in a slightly different form. We know from theorem 3 on page 86 that if 1 minus root 6 is a root, then 1 plus root 6 is also a root. Looks amazingly familiar like the quadratic formula, doesn't it? Well, that's where it comes from, but I'm not going to talk about that today. We're going to talk about a cubic equation, a third degree polynomial with 3 real roots, 1 minus the square root of 6, negative 3 halves, and 1 plus the square root of 6. So that's the deal. Now, to start with, in order to write an equation, we want to find the sum of these two roots right here. So we're going to go 1 minus the square root of 6 plus 1 plus the square root of 6. Well, 1 plus 1 equals 2, and minus root 6 and plus root 6 equals 0, so it's still just 2. And then we're going to want to find the product of these guys. And you can use a table or you can FOIL it. Just for a quadratic, I think I'll FOIL it. That gives us 1 plus 1 root 6 minus 1 root 6 minus 6. And that gives us 1 minus 6, which is negative 5, is the product. Cool. Here's the neat part. From your reading now, you know that I can just write this as x squared minus the sum, which was 2x, plus the product, which is negative 5. Now remember, this 2 right here, we've talked about this before. They add for that b coefficient, and they multiply for that c coefficient. And I should say equals 0. Very nice. So x squared minus 2x plus negative 5. We're cruising. Now, let's not forget we had another root earlier. What was it? I can't even remember. It was negative 3 halves. So if that is the case, then we can say, all right, x plus 3 halves times x squared minus 2x plus negative 5 will give us a formula for a cubic equation. And we probably want to simplify that a little bit just to make it nice. And this time, when we have 6 terms like this, I like to use a box. And my box is too big, but that's okay. Okay, I like it. I like it, I like it. Now, let's fill it in. So this one would be x cubed. This would be 3 halves x squared. This would be minus 2x squared. This would be, well, it would be negative 6x over 2, which will be negative 3x. This one will be negative 5x. This one will be negative 15x. Okay, there are 6 terms. So now we have f of x equals x cubed minus 2x squared. Because this term here has a 2, the 3 halves has a 2 in the denominator, I'm going to write this as minus 4x squared over 2. And you'll see why in a minute. Atlanta Gatherum dot there. Plus 3 halves x squared. Then we have minus 3x minus 5x and minus 15 over x. Let's see where we're going with that. So now we have f of x equals x cubed minus 7 halves x squared minus 8x. Why did I put this over x? I am tired. I apologize. 15 over x. Golly, it's late. Yeah. You're probably laughing at your screen at home. So this is minus 15 halves. 15 halves. That's better. Okay, so that is a cubic equation, but it does not contain integral coefficients. So we can multiply everything by 2 and get f of x equals, and you're thinking of this like 2f of x, which you're right, that would be a transformation. It would vertically stretch everything by 2, but it didn't talk about the requirements of this problem initially did not talk about local maxes and mins. It just says with those roots. And as you know, whenever you multiply by a coefficient, it does not change the roots. It just stretches things vertically. So we have 2x cubed minus 7x squared minus 16x minus 15. Oh, wait, I just saw another sleepy thing that I did wrong. You all are laughing again. I'm tired, I admit. Should have gone home a long time ago, but I wanted to make this video. So this was negative 4x squared, and positive 3x squared is just 4 halves x squared plus 3 halves. That's a negative 1/2 x squared. So this is not, and it's okay to make mistakes. I do it all the time. And sometimes I laugh at myself, and sometimes I get mad at myself. But most I say it's okay. Be good to yourself. And so this is going to be minus 1x squared, minus 16, minus 15. And there is a cubic equation with integral coefficients and roots at negative 3 halves, 1 minus root 6, and 1 plus root 6. And now you're saying, well, after all those equations, shouldn't we check it? And you would be right. So let's bring up our handy-dandy calculator and check that. Gotta get up a little bit higher so I can turn it on and put in an equation. 2x squared minus, that one's pretty close, minus 2x cubed minus 1x squared minus 16, is it? Okay, I got to get a little tricky here. Insert 6. Minus 15. Oh, 15's right. We're good. Okay, so we have minus 15 minus 16x minus 1x squared and 2x cubed. So that should work. I'm just going to hit zoom 6 to give me a nice 10, 10, 10. And let's check it out. Now these guys are probably going to be really close because negative 3 halves were good. That's 1.5. Yes, I hate decimals. And then Square root of 6. Well, square root of 4 is 2. Square root of 9 is 3. So the square root of 6 is like, 1, um, 2.4, something like that. So this is going to be 1 minus 2.4. So I think that is going to be negative 1.4. So these two are really close. And this is a time when having a calculator maybe doesn't help. You would think that was a double root. And then the next one would be about positive 3.4. About. And that one's about as well. So this is just a rough check. Okay. So let's, well, can we do it with our table? Let's check it out. Table. So if we're at 1.34, negative. I'm about to freak out there. Negative 1.5, there it is, 0, we get a root. Negative 1.4, we can't look at that one directly. So let's go and do table set and go down here to ask. And then ask and ye shall receive. And we're going to go negative 1.4. And it should be close to 0. It won't be exact because that's a crude approximation. It's pretty close to 0. And then we're going to go to 3.4. And that's pretty close to 0. And yeah, that graph is interesting because if we went zoom box 1 and really zoomed in right here, I'll bet you anything we'll see 2 roots. Well, we will, I know. But you can't see it just looking at it directly, and that's why we need to be good at what we do. So it comes up, look at that. You'd have to zoom box again. You can barely see that. It's pretty cool. Let's do it again. Sometimes you have to do it twice. But sometimes you can't even see it no matter how many times you zoom in, and that's why we need the math. That's why we need the math on our side. Let's see if we can see it this time. Yep, there it is. Look at that. So there are 2 of our roots, and the other one's over there at about 3.4. So, and you can trace it if you want, get a little closer. It's crude though. Trace is crude. You couldn't go second calc. 0 is better. So at negative 1.5, this looks like a number, but notice this e to negative 5. That means 0.00002. So this is very close to 0. And then over here, we go to, and again, negative 1.5, 9.15 times e to the negative, times 10 to the negative 4. That e makes me crazy. So that's 0.00009. And again, that one works too. And we can get closer to that. So our check works. We wrote an equation, f of x equals 2x cubed minus 1x squared minus 16x minus 15. And this equation has roots at negative 3/2, at 1 minus root 6, and at 1 plus root 6. So that was very useful. And that is all. So I'm signing off. Hopefully this is helpful. Have a good day.